Our next speaker and I chatted at Wellingtaru and agreed that he worked hard to build his introduction into his talk, so all I'm going to do is cover his entrance by saying his name. It's Jeff!
All right, let me just imagine that 20-minute period didn't happen, and I'm going to kick off. So kia ora, this is my talk where I convince you that maybe it's a worthwhile endeavor to build your own game engine for fun. So here's where I start. I'm just going to talk about myself to begin with. I'm Jeff. Online, I'm Peebnuts. That kind of started off, it was supposed to be Peanuts, but I made a typo when I was signing up to Neopets. And there you go. So I've been a software developer for 12 or so years, but I've done game dev as a hobby for more than 20. When I put that on the slide, I kind of like turned into a skeleton and then like fell to the floor as a pile of dust and then blew out the window. No, but over the years, I've kind of had to go at all of it. I've done like game design, I've done concept art, and I've done sound effects and music and writing. And for a period of time in my teens, I told a lot of people that I wanted to get into 3D modeling, which kind of raised a few eyebrows, I think, because it was before I learned some terms like maybe 3D artist. But I say all that just to kind of pitch to you that I haven't worked in games. I don't actually have any real world experience from being employed in this domain. Quickly start my timer, because that's quite crucial. But that's what we're learning today. So we start here. So my partner's here. She'll know that I've always wanted to grow wheat. That's because I always wanted the satisfaction of like making my own loaf of bread, like entirely from scratch, like my own loaf of bread. I was very curious about like the process of, grinding wheat into flour and all these sorts of things. Now, despite being a relatively achievable goal, I've not actually done it. But there is this man. His name is Andy. Some of you probably know him. About 10 years ago, he made a project to make a sandwich from scratch. He wanted to do that, and he documented it on YouTube. So he grew like all his own wheat, and he milled it to flour. He grew cucumbers, and he pickled them. He like pressed sunflower seeds down to oil for mayonnaise and stuff. And he did it. He made a sandwich. And videos like this are why we did all that rigmarole. Oh, the sound is going to be another question, isn't it? Not super audible. Oh, yeah, okay.
It's not bad. But it's not bad. 6 months of my life were not bad. Yeah.
So, it was okay. But he learned stuff. He learned a lot of stuff about the different parts of making a sandwich, right? He learned about harvesting animals and cultivating bees and all these sorts of things. So he actually loved doing it so much that he made this YouTube channel. It's called How to Make Everything, because he wanted to learn about everything. So I think that much like Andy's quest to to make a sandwich from scratch taught him all about making sandwiches and all the bits that go into that making a game engine will teach you all the different bits of game development. So here's my pitch to you. If you do something like this, an exercise like this, it will make you better at your work, possibly better at working with other people. It might make you kind of the weird person at the meetup who always talk about their own game engine, and if that happens, I'm sorry. So even though it seems like kind of a difficult task, I want to convince you today that it is actually achievable. I want you to feel like you could do this. Now, this talk is from a technical perspective because I'm a technical person, but this is not a technical talk. I'm not going to have like code on the screen or anything like this. I want this talk to be accessible to every person. So this is kind of the journey we're going to go on. We're going to sort of make a game engine step by step, and we're going to stop in at like 3 lessons along the way, or 3 goals. So here's kind of the first goal. We just want to draw something to the screen. Anything is good. We're going to equip with us a few things. The primary thing is this magic wand, which is going to allow us to skip over some things to get to more interesting things within the scope of this talk, because we've only got 30 minutes, and let me tell you, this did not take 30 minutes. The other thing we're going to arm ourselves with is OpenGL, and this is kind of the first lesson. OpenGL is a renderer. Renderer is a thing that can display stuff to the screen, like models and textures and sprites and things. This may seem like kind of a big thing to leave out of making a game engine, but I promise you there's a lot more interesting stuff outside of that. These things have been optimized for like 30 years now. They are extremely efficient, and they are very difficult to make yourself in a way that's good. So we're just going to use that for this talk. So here's kind of where we actually start doing something. This is how we draw something to the screen. So this is a core concept that we're going to talk about. So we've got these two things. We need two things to be able to draw some stuff, to shape some things to the screen. We need a list of vertices, which are just points somewhere in space, and we need a list of triangles. A triangle is just a shape that's joined from any three of those points. If we give these two lists to OpenGL and we say, please draw this, it'll draw it, and it'll be like, here you go. So we can use that to draw something maybe a little bit more interesting, like a cube. In this example here, we've got, a cube has 8 points, so we've got 8 vertices. The 8th vertex is actually behind the cube in this example. Each face of the cube is 2 triangles, and each triangle is made out of 3 of those points. Now, all these triangles are sharing these same 8 points. So again, if we say, hey, OpenGL, here's our list, please draw this, it'll do it. Now, a cube's great. You know what's better than a cube? Is basically any shape. So how might we get a shape that's more interesting? So let's look at loading a shape from a file so that we could maybe make some 3D models in something like Blender and then just sort of display them in our thing. So here's an excellent 3D model that I took off the internet. Thank you to this artist. How might we load this into our thing? So we're gonna hold on to these core concepts that we need these two things, a list of vertices and a list of triangles. And then we're gonna go look at what's actually inside this OBJ file. Okay, well, it's kind of a bunch of gobbledygook. But if we look at the spec and we look a bit closer, we'll see that each line here starts with a letter V, and actually turns out V stands for vertex. And following the V is 3 numbers. These are the coordinates of these vertices. 1 line per vertex. We look further down the file, we've got these lines that start with F. That stands for face, which is basically the equivalent of our things which we're calling triangles. This is a little bit more complex because instead of having 3 numbers following, it's got 3 groups of numbers. But the first number within each group is the position of the vertex. The other 2 numbers are things like vertex normals and texture coordinates and things, and we're just skipping that with our magic wand. So if we take a little step back out of the weeds, we recall that we need these 2 lists to display stuff on the screen, and guess what's in the file? A list of vertices and a list of triangles. So we don't even really have to do anything too much. We just have to kind of read them out of the file and then use them in our engine, and it's all good. So if we do that, we get, the platonic form of a rat on screen. So we've learned what a model is, but kind of so what? Now this might seem trivial, and it is, but we can already learn things from other domains now. For example, if we look in Blender, we've got these 2 options. We've got shade smooth and shade flat. And if we export 2 copies of our model, one shaded flat and one shaded smooth, into our engine, we'll see that it already kind of works. It's already doing the thing. But we didn't really do anything. We haven't sat down and supported this feature yet. So how does this work? Okay, on this slide, I really wanted to show that there was this big difference between the 2 files, but it turns out that even despite being a 35-year-old file format, the OBJ file format is actually too powerful and completely works around the problem that I'm going to talk about. So let's look at a slightly more modern format. This is more what I was looking for. So we see that actually, if we look closely at our models, that the flat shaded version is almost 3 times the size of the smooth shaded version. What's going on? Well, here's what's going on. So smooth shading is kind of what we've been talking about. We've got like the 8 vertices and the triangles all sharing the vertices, and it renders smooth. It gets all blended because all of the faces are joined. Now in the flat shading one, all of the triangles actually got their own copy of all the vertices. And so all of the vertices are duplicated for every triangle that's connected to it, which is why it's bigger. And because none of the triangles are joined, it doesn't render smoothed. Now that's kind of an oversimplification because in real life there's things like vertex normals and stuff which are at play here, but for the sake of this talk, this is good enough. So really the lesson here is maybe with a better understanding of what models are, we might be able to work better with artists. For example, if you're having a discussion of art style for your new game, you might be able to say, hey, this flat shaded art style, it will actually have maybe more use of memory or something like that. Now, our example was like 50 KB more memory, so like I don't know if that's going to super matter, but maybe if you had a lot of models and they were very complicated or something, maybe. But the lesson here is that even learning a few very basic concepts about what art and 3D assets and stuff are is that we're already a little bit better equipped to communicate with our artists. So now we're going to wave the magic wand, and we're going to add texturing to our thing, and the ability to like have a few things on screen at once. I hope you feel like that's not like a super big leap from what we've been talking about, but it's not even interactive yet, so it's not even really a game. So let's talk about input. Now this is our second goal, which is allow the player to interact with the game, and we also need to instruct them like how they can do that, say as on the screen or something. Oops. Now, input's one of those things where like it seems kind of simple, but the more you think about it, the more complex it gets. You sort of like fighting with like a thing of quicksand or whatever. Because you might initially think that input sort of seems something like this, where you're like, if the player presses the A key, then they go left, right? But you're already screwed, because we've got things like this. Keyboard layouts. Now, keyboard layouts are kind of different all around the world. For example, in like France and Belgium and things, we have this AZERTY layout on the right, where the A key is in a completely different place. And actually, if you look at the normal WSAD keys, they're not even really in like a good layout that would allow a player to like control your game good. So what do we do here? What can we do about it? Well, we have something called scan codes, which is basically a numeric value assigned to every key on the keyboard. And this is supposed to represent like a physical location on the keyboard, not change based on your layout. Now you might think that we can solve our problem with this if we change our logic to something like, instead of the A key, it was like if the player presses the key with scan code 31, then they move left. But what you find is that you've actually kind of just moved it around, because eventually you have to display something on the screen that tells them what button to press. So you have to like translate scan code 34 back to F based on the current layout, and then it's going to change based on where they are in the world and all these sorts of things. So it gets even more complicated if we start thinking about rebindable controls, because we have this whole extra layer of abstraction on top of it, where now we're like, if the player presses the jump button, and the jump button is mapped to scan code 61, and then the scan code 61 is mapped to the space bar. So we have like all this mapping going on. So what do we do about this? What can we actually do? Nothing. You can't really do anything about it. Ultimately, you have to have this like whole translation lookup between this and that somewhere in your thing. Now, the saving grace is that if you are actually building a game engine, that you probably don't have to implement this yourself. You've probably got something somewhere that has already sort of done this for you. It might be your operating system, or if you're working in the browser, it might be the browser. Or if you've got an input library like SDL or something, it might be doing it for you. But that's just for keyboard. Like, we haven't even talked about other things like mice or touch inputs. Don't think that this is any easier if you're going to be using game controllers or less common devices that your players are absolutely going to expect to be able to play your game with. So once again, I'll ask, have we learned something here? And the answer is actually yes. What we've actually learned here when we've observed input and things is about game design. Input is the representation of our players in our games. So when we look at input and we find that it's complex, we shouldn't be surprised to find that it's complex because our players are complex. Now, given this, we might say that if we have some kind of development problem to do with input when we're building something, that might actually imply a problem for our players. For example, if you've got a rock climbing game or something where like the triggers are like how tightly you're grabbing onto the rocks or something, well, you can't put that on Nintendo Switch because it doesn't have analog triggers. So you might ask yourself, is our control scheme too complicated? Let's check back in our engine. So I think it looks pretty good. I mean, I made it, but it kind of sounds a lot like every game prototype I've ever made, which is completely silent. So let's talk about sound. Now that's just a note to myself. So our third goal is that hearing players can hear your game, obviously. What's the point of sound? Well, how? It can provide feedback. It can reinforce other feedback that's happening. It can convey tone. It can convey emotion. It can give context. You can just whip out your like dope soundtrack. But sound is obviously can be very valuable in many ways. I can't tell you the number of times that I like added sound to something that was completely silent previously and then gone like, oh, the controls are wrong. Or like, oh, this is way more fun than I thought it was. So let's talk about sound. Let's talk about adding sound. Now, I kind of want to skip over sound a little bit because what is sound? Well, it's kind of just like vibrations that get stored in a file. Files like this. Now, loading these files and getting the vibrations out of them is like another one of those things that you probably like don't really want to implement yourself because it's just a sort of a solved problem. We've got all these, Robert's nodding. We've got all these file formats and they're just solved problems. They're just a spec. You don't want to have to like sit down and work through that. There'll probably be something that you can use, like the operating system or the browser or whatever. Now, on the other end, playing sound is also probably something that you don't want to have to really do yourself. It's probably something that you just have available. It's just go play this sound for me. So the question is, like, if loading sound and playing sound are both very easy, like, is sound just kind of done? Is sound just easy? Well, no, it's everything in between that is interesting about sound. For example, if you've got sound in your game playing from like a stereo and your character like turns around, like you want it to pan left and right, right? You can do that. I was going to give you a spiel where I kind of convinced you that it was easy, but it actually turns out it's very difficult. But you can do it. It's doable. For another consideration is like, how far away is the sound? We know as it goes further away from you, it needs to get quieter. And there's many ways that you can do this. You could have like a max distance, and the sound gets quieter, like linearly as you approach that distance. Or on the right here, you can have some kind of like 1/x function, which it drops off very quickly, and that's a bit more realistic to reality. But it kind of just depends on what you're trying to do. And similarly, you might have like sound in a cave or something, and you want like some reverb or effects on it. Was that me? I've probably got a meeting on. Should get going. But you might also have like a character talking from behind a wall, and you want their voice to be like muffled or something. It kind of just depends on what you're trying to do, what things you're going to implement. So this is what sound design is. This is sound design. Now, this is probably the area that I know the least about, but that's kind of why I wanted to talk about it today, because having to sit down and like ask myself all these questions and think about these problems kind of forced me to learn a lot about sound design as a discipline. Now, the lesson for this goal is actually kind of that doing these exercises kind of made me better at listening to someone who is experienced at it and understanding what they're talking about, which is kind of contrasted with the first two goals, which are maybe a bit more around communicating something. Because, you know, communicating and working with people is not one way, it's two-way. So our game engine, we'll play this in a sig. Our game engine is already pretty featured, even though we've only covered like 3 major areas. I think that we can make a game with it. If you're ready, you can see the game that I made with it. Please play. If the III Initiative are looking for candidates for the next showcase, I am available. But this is just something we've cobbled together, right? We've just covered like a few steps, a few areas, a few things, and we've already learned like a bunch of things, and we also skipped a bunch of things that we would have also learned if we had done as well. Got to bring the mouse to the other screen. So I've been working on this project, which is called PolyZone. Now, PolyZone is a fantasy console for creating, sharing, and playing in PS1 and N64 style games. PolyZone is not just a game engine, but it's also an editor, so I'm kind of taking on like major psycho stuff that I want to get done, but here's some of the stuff that I've made with it thus far. Now, PolyZone is a long way to go, but I've already had to implement a lot of stuff, like all the things that we covered today, and all the stuff that we skipped over with the magic wand. I had to do materials and collision handling and like undo. When I saw the theme of the conference was checkpoint, I really like sat down and just reflected on like, what have I learned? What have I been doing? And I thought, wow, I've had to engage in all these things, and I've had to learn so much stuff about all these different disciplines. This has been so valuable to me. And so I kind of wanted to like submit this talk to share this exercise with everyone. Because actually, this talk isn't really about making a game engine. It's actually about learning more from and about the people around you. Learn about their disciplines and their skill sets. This is kind of just like my way of doing that uses my strengths to learn about other people's strengths. It can be like a lot easier to pick up stuff or learn something or be engaged with something if you do it in a way that you're already familiar with, rather than just kind of like throwing yourself at a completely unfamiliar domain. And I think anyone can do this. I kind of struggled a bit, like submitting this talk and writing this talk, that I was worried that this was just a technical exercise for technical people or programmers. But I've come to the conclusion that it is not. I think that it is for everyone. And here's some examples that I came up with. If you're an artist, for example, you could make fake screenshots of a game that doesn't exist. And it forces you to think about what's on the UI. What is the player looking at? Why are they looking at those things? What's interactable on the screen? How does it work at different screen sizes? You kind of have to reverse engineer a whole game just to be able to do this. Similarly, if you're a writer, maybe you could do a writing exercise where you write about the perspective of a player who sits down and they boot up the game. What are they looking at? What menus are they going through? What are they confused about? Like, what are they really excited about? What are they like doing? All the way up until the game starts. You could do a very similar exercise for sound, for making audio from like a game that doesn't exist or something. If you're a designer, maybe you could design a game about being an artist. You have to think about like, what concerns does an artist have? What do they have to manage on their screen? What are they doing? I don't know. Are these good examples? I don't know. But I'm willing to bet that if me, a programmer, can come up with like some half-baked, semi-good sounding ideas about how to do this exercise, that you, skilled in your domain, interested in the things that you are, could probably come up with some examples that actually are good in learning about other people's domains. Because really, the point is just that. Learning about other people's domains makes it easier to work with other people and easier for other people to work with you. Thank you.